Okay, the call is now being recorded. Okay. Kita mulakan dengan umul kitab Al-Fatihah. Bismillahirrahmanirrahim. Iyyaka na'budu wa iyyaka nasta'in ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Bismillahirrahmanirrahim. Allahumma iftah 'alaina hikmataka wanshur 'alaina min khazaini rahmatika ya arhamar rahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Okay, the fundamental of discrete mathematics. What you will learn in this subject is about discrete mathematics, and like the word itself, discrete means discrete elements. Discrete lawannya continuous. Saya rasa saya dah sebut minggu lepas. Dan discrete ni adalah elemen yang countable, berbeza, distinct. Okay, so we cut chase to that. Kenapa kena belajar discrete mathematics? Saya tak nampak muka saya lah. Okay. Okay, why we need to learn discrete mathematics? Okay, so I believe it's important for you to know why certain subject is important for your career development as a data scientist. Data scientist, like you dah pergi lah introduction to data science. Data science comprises of many skills. Okay, mathematics, you should have the basic of statistics, programming, and also the knowledge domain. Discrete mathematics will enhance your skill as a programmer. Basically, dia membantu kepada programming skill. Dalam discrete mathematics, for your first chapter, for example, logic, kita akan belajar logic. Logic will help you to understand how to develop a program in terms of the flowchart. Flowchart, pseudocode nanti yang korang akan do. Kalau untuk program to execute dengan betul, you must have a necessary step. Step 1 apa, step 2 apa. Dan sometimes you have rules. Dan kita akan tengok rules tu semua daripada segi logic. Logic akan membantu kamu dalam pembentukan rules berikut. Okay. Alright. So ni outline je. Okay. This is the application. Of course, like I say, it's more on the programming side for this chapter. Okay, apakah itu logic? Okay, sometimes when you heard this question, sometimes your friends say like this, what do you say is not logic? Apa yang kau cakap ni tak logik? Okay, logic tu apa sebenarnya? Can someone try to give the answer? Logik tu apa? Tak nampak muka lagi. Orang kata kan, apa yang hang cakap ni tak logik lah. Logik tu apa?
Benda yang masuk akal.
Benda yang masuk akal. Ya, betul. I like that. It makes sense or not. Logic, like your friend say, Fahana je. Okay, Fahana. When it translate into English, makes sense or not? Logic. Actually, it does not state whether it's true or not. Logic, it makes sense of it. Basically, logic is a science. Saya masihkan dia dalam bidang sains. To evaluate argument. I repeat, logic is the field of science that evaluate argument. It stems from two major branches. If you heard about Aristotle, zaman-zaman Rome dulu, Greek bukan Rome, Greek. Saya pun bengong sikit geografi dan sejarah ni. Falsafah, logic stems from philosophy and also mathematics. Sometimes you read about logic, they more on the paradox, apa semua tu, itu bidang falsafah. Mathematics is they how to formalize the language into logic. Right? So in order to do that, in order to evaluate the arguments, we must start first with what is actually a sentence, a proposition, a statement. Kita kena start dengan penyataan. Okay? Proposition is a declarative sentence that can be answered either by true or false. Cannot be both. Choose one. True or false. Okay? There are many a declarative sentence which is actually not a proposition. Okay, for example, like this. I love discrete mathematics. You ask yourself back, can it be answered as true or false? Okay, I try tanya you all. I love discrete mathematics. True or false?
True.
Eh.
True.
True. Kita bagi
True.
jawapan.
Okay, so if you can answer it by true, or tak kisah pun kalau false pun.
Why?
Okay, but the thing is, the proposition, it can be answered by true or false. So basically, the statement, I love discrete mathematics, itu adalah proposition. Okay, ayat penyataan, fakta yang boleh dijawab sama ada true or false. Okay, we have to bring 8 glasses to true or false as well. Okay, tetapi, okay, however, there are certain declarative sentence like a question which we cannot say it's a true or false. For example, how are you today? Orang tak akan jawab, true. How are you today? True. Benda true lah. How are you today? I'm fine. I'm not fine. So that kind of declarative sentence for question, command, apa semua, itu bukannya proposition. That is not a proposition. It is a foundation that we know about the proposition or not because we want to put arguments. Arguments, kalau you perasan, dia mesti dalam bentuk proposition. When a lawyer speaks, they give the argument. Bukannya waktu dia nak soal witness tu, no. Waktu dia berhujah. Okay. Wakil rakyat contoh dalam sidang parlimen kan. Kalau dia nak bahaskan isu, dia kena sentence, proposition, then conclusion. Okay, this is my example of such argument. Okay, contoh. Kalau orang tinggi, okay, if the person is tall, selalunya dia gemuk. Saya tak kata betul ni argument If the person is tall, usually they are fat. Sir Adam is tall, therefore he is fat. Bila kamu dengar statement tu, itu hujah. When we have an argument, then I have a conclusion. My argument just now, if a person is tall, then he is fat. Sir Adam is tall. My conclusion is that I guarantee that he is fat. Okay. That kind of argument is actually logic. Okay. Saya bagi tahu terus lah. Nanti kita akan tahu macam mana kita nak buktikan logik ke tidak. Argument saya tadi. Actually, that statement makes sense. But in reality, contohlah, saya tidak gemuk. Tetapi argument tu make sense. So how to ensure the statement is true or not? Is actually accurate in reality or not? That's why we need proving. Logic just manage to evaluate whether that argument is valid or not, can be used or not, that kind of argument. Structure dia tu boleh ke tidak. However, to add up to the accuracy of that statement of the fact, you need proving. Alright. So when you have the foundation of logic, you can develop your own program, computer program. But in programming, later you will learn there is some error. Error tu dinamakan logical error. You always heard about syntax error. Syntax error ni, you put the coding, you mistakenly put a coding, argument command tu silap, tak boleh nak generate outcome of the coding. However, one error that cannot be detected by any programming language is the logical error. Logical error, dia boleh execute the program, but that program doesn't really make sense. That's why you need to prove that actually your writing of the program can execute the results that you intend it to be. Okay, logic kawan dia, pelengkap dia ialah proving. Alright. We proceed to the next one. Saya tak payah tulis lagi lah, nanti kita kena tulis. Alright. Okay, now it's a proposition. You tahu dah beza proposition dengan tidak Proposition can be answered by true or false. Yang apa-apa sentence yang cannot be answered by true or false, that is not a proposition and cannot be used in any argument. Okay, now we talk about compound proposition. Okay, you have many proposition and you sorry, not that you have many, okay? You have two types of proposition. First, atomic. Atomic, it means a single proposition. Just now I used in my example, the person is tall. Itu satu proposition. Sir Adam is tall. True or false? Satu proposition. However, if I want to add up another proposition, which is Sir Adam is fat, so itu proposition yang lain. And there is many ways to combine those two propositions. Okay, I repeat. The first proposition is that Sir Adam is tall. The second one is Sir Adam is fat. And how to combine? Banyak cara. For example, yang paling simple ialah Sir Adam is tall and Sir Adam is fat. Two proposition is combined into a single proposition that is known as a compound proposition. And how to combine two atomic proposition into one, we call it logical connectives. Tadi saya guna apa? Saya guna and. Dia boleh juga or. Dia boleh juga not. Ni contoh, dia ada 5 yang kamu akan belajar dalam kursus ni, ada 5 logical connective yang wajib diketahui. Okay. Ada soalan setakat ni? Tak ada, diam je. Kalau ada baru ni. Kalau tak, nanti kan 63 orang ni, tak ada. Tak yalah, so kalau ada je. Okay, it's still simple at this time point. Okay, sebab tak ada kira-kira, kita baru tahu definition. Okay, kalau ada cakap you can if possible to ask the question, wait for the opportunity when I give you. Kalau bahayanya, bukan tak boleh tanya soalan, takut saya tengah terangkan pasal content, takut tergantung saya punya penyampaian tu, nanti saya lupa nak sambung balik. So ada ruang nak bertanya, saya akan bertanya macam ni lah. Do you have any question? Then at that time you interrupt, you masuk. Okay. Alright. Just now we know about that two types, atomic and compound. Okay. Atomic single, compound more than two and more proposition. In logic language or logical syntax, cara penulisan logic, they usually don't write it very long. Macam English panjang, Sir Adam is tall. However, that one can be summarized, simplified into what we call as a propositional variable. Matematik ni dia suka bagi simplekan benda dalam bentuk variable. So, just now, my proposition just now can be put into a single alphabet letter, PQRS. Selalunya, I pun tak tahu kenapa logic start daripada P. Dia tak mulakan daripada A. Tapi tak ada masalah pun kalau kamu nak tulis A ke apa, B ke apa, C. The point is you represent a long proposition into a single one. Okay, let's look at this one, P. Okay, saya nak mula menulis. Alright. P, dia tulis kat sini. Allah, warna PK. P, making just few changes in your lifestyle can help you live longer. Panjang ya contoh ni. You live longer. Whereas another proposition is Q. Healthy eating is about eating smart. Okay. As shown here, you have two atomic proposition. Atomic proposition P and atomic proposition Q. And I also can combine. For example, just now I already give you the example P and Q. Okay. If I say in English sentence, what will be P and Q? Senang je. Okay, you can just say P and Q means making just few changes in your lifestyle can help you live longer. You letak, and healthy eating is about eating smart. You boleh letak and, you boleh letak or, you boleh letak not di mana-mana. Okay, nanti saya akan bagi contoh lain lah. The thing is, this long English sentences can be translated into this short form P and Q, and lagi pendek kalau boleh buat P and Q. This is a symbol of N. Okay. Now we go to the truth value and also truth tables. Whereas we want to show whether the argument is logically equivalent or valid or not, we need to transfer this declarative proposition into a truth table. Truth table, macam mana nak ajar truth table ni kalau tak guna contoh? Okay, simpan dulu dalam kepala. Truth table nanti, you will represent your P and Q in terms of whether it is true or false. Okay, so true value, nilai, true nilai, you only have two, which is either true or false. It cannot be both. Ingat kepada asas dia balik. And this truth table will show you to represent those logical connectives, how we compound the proposition, then we can use it to determine many properties afterwards. Okay, bear in mind true value, T and F sahaja. Okay, ini bosan, saya tukar dulu. Bolehlah. Alright, we do a simple thing that is not in the slide. Okay, P, today is Thursday. Contoh ayat pendek macam ni yang saya suka. Okay, apakah dia not P?
Today is not Thursday.
Very simple, right? Very simple, right? Today is not Thursday. Alright, we can also change what is P and Q. Senang juga, tak perlu jawab, saya tahu kamu boleh jawab. Today is Thursday and you will get summon. Summon. Tiba-tiba. Memang dengar ni apa ni? Hari ni Khamis dapat saman. Saya tak tahulah, mungkin ada lah. If you drive. Nampak dia ada if you drive. Maksudnya kita kena saman hari Khamis je. Over 110 km per hour. Okay, you can also have P or Q. Which is, okay, you already got it. Today is Thursday. Or you will get summon and blah 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 blah. Okay, the skill to transform from the left here to the right and also from the right to left here, you need to master it. Nampak simple, however, some of your seniors still do this kind of mistakes because they do not emphasize this logical connective. Dia tak master penggunaan logical connectives tu. Not, and dengan, or. Okay, this is logical connectives. Okay, dia ada 5, nanti saya tunjuk. Okay, there are 5. The negation, conjunction, disjunction, conditional and biconditional. Okay, this is not in the slide. Dia ada ke tak dalam slide? Saya pun tak ingat. Okay, this one. Precedence of logical operator. In arithmetic calculation, you have what we call as a board mass. Korang dah belajar dulu daripada sekolah rendah. Bracket, order, division, multiplication, addition and subtraction. You must enforce to prioritize on the bracket first. Dalam logik pun ada benda tu. Okay? Tapi dia bukannya division apa semualah. Dia logical connectives. So what I want to show you right now is to enhance this table. Cukup ke? Okay. First we start with sekejap, ni apa nama dia? Bukan. Type. Type. Okay, dan saya buka balik. This is a logical symbol atau operator. Nah, ni logical, connective lah dulu. Connective. Ini simbol, barulah precedence. Precedence. Okay. You have 5, but let me put one more, which is bracket. Kadang-kadang student lupa pasal bracket. Kita buat benda dalam bracket dulu. Ni adalah bracket. Bracket bukannya logical connective. So saya tak mau letak kat sini, tetapi dia patut jadi priority yang nombor 1. Okay. Then kita boleh letak negation. Negation, not, dia punya symbol, it can be either this one or this one. Ni saya tak hafal ni, conjunction dengan disjunction ni. Conjunction and ke or? Saya tak hafal, serius.
And
Okay, conjunction dulu okay, and. Thank you. Okay. Conjunction. Allah buruknya. Saya rindulah tulis kat whiteboard jap. Conjunction. Okay, conjunction and bentuk dia inverted hat. Disjunction or simbolnya ini. Alright, then is a conditional. Conditional if blah 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 then. And the arrow is to the right, tak ada arrow to the left, semua ke kanan. And lastly, by conditional. Okay, by conditional, dia punya logical connective dia ialah if blah 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 and only if. 2 arrow, left and right. Okay, itu je lah saya nak enhance nota ni. Alright, then kita akan belajar nanti macam mana kita nak develop truth table. Okay, kita pause 5 minit. 2 minit je lah, saya nak charge. Betul lah budak tu cakap cepat habis bateri. Saya nak pasang charger sekejap. You can add up this into your notes or you just can remember kot, kalau boleh ingat. I also happen to know that some of you guys or girls already learn about logic sewaktu diploma kot. Okay. So use that to your advantage. Maksudnya you dah belajar, patutnya yang ni senang je. And yes, logic is the easiest chapter for this course. Jarang budak tak dapat jawab kecuali budak yang tidak belajar. Sengaja saya susun di awal sebab memang kebanyakan textbook discrete mathematics dia letak logic di awal berserta proving. Ironically, logic senang. Tetapi pelengkap dia, the complement which is proving, itu susah. Bukan saya cakap, student yang komplain. Wait mana? Oh sini. Okay, we proceed back with the truth table. Okay, with the connection of it with logical connective. There are some properties associated with all of this logical connective. We start with the simplest one, which is the negation or not. Okay, as you look in the slide there, This is for not, P. It can either be true and it can either be false. The basics of developing the truth table stems from this symbol, 2 to the power of n, where n represents the number of proposition. Basic there. So because these properties of negation just involve one, which is P, then you can have 2 to the power of 1, which translate into 2 rows. Ni number of row, 2n ni ialah number of rows in truth table. Okay. So as shown there, P, the opposite of P is not P. So T, if not P, it becomes F, and F, the opposite will be T. So let's put this into the practice. Nak contoh apa? Contoh tadilah, sorry. Sir Adam buncit. Okay, right now you tak tahu perut air buncit ke tidak. Sir Adam buncit, true or false? Kita tak tahu. However, if it is not P, Sir Adam not buncit. Okay, let's make this into this sense. Suppose Sir Adam buncit is true. Katakan betul lah saya buncit. So, the first statement Sir Adam buncit is true. So, Sir Adam is not buncit will be false. Itulah logik dia. First statement kalau benar, true. So, the statement in not P will be false. And vice versa. Senang kan? Not lah paling senang. Okay? So, saya tak nak lama sangat dekat yang senang ni. Saya terus kepada yang susah. Sikit. Okay, conjunction. Right now, we have conjunction, N. So, right now it involves 2 proposition. So, just now I said that 2 to the power of N represent number of rows. Right now, we have 2 propositions, P and Q. Therefore, you should have 2 to the power of 2 exhibits by 4. First is P and the second is Q. Okay, right now to ensure that my student give the standardized answer, okay, sometimes student dia tak letak T dulu. Sebenarnya tak ada masalah. However, to ensure that to have a standardized answer, tolong tulis TTFF. TF. In this order, to ensure that you don't have redundant answer. Sorry, no. To ensure that you don't have redundant combination. Kalau TT, TF, FT, FF. Different combination with a different order. Kenapa saya cakap tadi, saya nak student jawapan standardized. Okay, ni tolong jangan buat lah. Tapi kalau kamu buat, kamu tidak salah. Dia letak F dulu. Okay, yang ni dia buatlah TF, PF. Alright, P and Q according to the properties is this. T and T is T, the other combination is false. Kalau kita yang pergi kedua ni, student tu dia kata tak nak menyusahkan Sir Adam nak marking. F and T still akan sama juga properties. F and T is F, F and F is F, T and T is T, T and F is F. When you see like this, the order of the truth value is already different. Yang ni saya baca T, F, F, F. Yang ni budak ni saya kena baca F, F, T, F. Technically, this order you can have 4 kinds of answer. Kalau susunan dia berubah. So, please saya cakap for the first time and the last time, please follow this order. Supaya saya tidak tersilap makin kamu punya jawapan. When I mark, I just read this, T, F, F, F. Tetapi, if the answer is different, saya tak kata student tu salah dulu. Saya akan check pula aturan dia. Sama tak? Kalau sama, jawapan dia lain kat kanan ni, bermaksud dia salah. Okay. What happen if you have more proposition? For example, if I have P and Q and not R. Tu dia. Okay. If you have 3, still use the same formula. You have 2 to the power of 3. You should have 8 distinct rows. And please use the same order of representation of the initial tableau there. P, T, 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 T 4 kali, F 4 kali. Q, T 2 kali, F, T, T, F, F. And lastly paling senang, R, T, F, T, F, T, F, T, F. 4 times T, 2 times T, alternately with F, and R, 1T, 1F. If you do this in this manner, it is more likely you will not have a duplicate rows. Okay? Alright. Ada soalan setakat ini? No. Okay. Ke saya cakap sorang-sorang ni, tak nampak muka kamu. Okay, ya. Yeah.
Yang kan tadi kan sebabkan 3 kan?
Yep.
Boleh jadi dia lagi banyak ke?
Boleh kalau saya nak gatal letak 5.
Lepas tu kan kan macam first row kan dia ada step dia kan. Kalau yang keempat pula macam mana?
Yang keempat. Kalau
maksudnya
ada 4. Okey. Kalau ada 4. Muhammad Akram, kejap.
Terima kasih.
If you have 4,
Maksud dia 4 elemen ke, sir?
4 proposition, bukan 4 elemen. Lebih tepat 4 proposition. If you have P, Q, R and S. Tak kisahlah logical connective mana saya nak letak nanti. Berapakah row yang kamu kena ada? So 2 to the power of 4 represents 16 rows. Banyaklah. P, Q, R, S. So how many P should be there? How many T in the P that should be there? 1, 2, 3, 4, 5, 6, 7, 8. 8 T. Lepas tu 8 F. 1, 2, 3, 4, 5, 6. Tak cukup. Okay. Q. Tadi ni 8 kan? Q pula. 1, 2, 3, 4. 1, 2, 3, 4. Then repeat. For R, T 2 kali, F 2 kali. T 2 kali, F 2 kali. For the last one, paling senang, TF, 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 TF. Dan repeat repeat pattern dia. So yes, you can have many atomic proposition that you like, but the formula remains the same. 2 to the power of n. So kalau lah kan, saya sengaja nak dajai kamu, saya kata dalam final exam P, Q, R, S, T, U, V. Ada berapa proposition ni? 7. Berapa row yang kamu kena buat untuk dalam truth table? It's 2 to the power of 7.
1 to 8.
1 to 8. Takkanlah saya nak tanya dalam exam sampai 7 kan? But technically yes. Theoretically it can be done. Alright? We go back. Ada soalan lain tak? Tak ada kan? Alright. We go back. Tadi dah negation and conjunction. Kita balik kepada properties conjunction. Okay. Yang ni saya tak nak tulis balik sebab memang dah ada dalam slide. only when both atomic proposition exhibits T, then you have T. Otherwise, false. For or disjunction, P or Q, only when both of them is F, then it will be F. Otherwise, it will be true. And a popular question that I get from my student is that, sekenapa le? Kena hafal jawapannya. So please ensure that you memorize these basic properties. And I advise my student to put in one page. Dalam satu page tu, semua logical connective ada kat dalam beserta table properties dia. Baru senang kamu nak jawab soalan dan kamu senang ingat. Dalam exam memang tak bagilah. Sebab ni bukan formula. Okay, ingat Alright. Just to test you kita mula buat satu truth table. Kita dah belajar 3, kita ada 5 kita dah belajar 3. Just now I put this question like this. Okay, develop a truth table for P and not Q. Senang je. Okay. Okay, please concentrate because we are actually trying to develop the truth table based on what we already learned just now. Okay, we start first with the fundamental. You have true proposition, P and Q. So you have 4 rows. P, Q. Initial dulu. Kanan kita tak habiskan lagi. So P, P, T, T, F, F, T, F, T, F. Okay. Next, which is we need to prioritize first. It will be not
Q.
Not Q. Cantik. So, when you look not Q, you don't look at P. You only focus on Q. If this is T, this will be F. If this is F, it will be T and you continue. Dalam nota negation ni tak ada Q, tapi this is the basic properties. When we try to translate here, T opposite dia F. F lawan dia T. T not dia F. F not dia T. Then after you prioritize not, then you can focus on P and not Q. Okay, for this one, mana pemadam ni? Okay. For this one, you don't actually need to see Q anymore. You only focus on P and Q. Focus on these two column. P and F dia akan jadi
F.
F. P and T.
F.
T.
T.
F. And also
F.
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 Senang But
Sir,
yeah, bercakap.
kalau tiba-tiba terlupa dah kan nak tulis T dengan F kan, kita tulis 1010 macam mana?
Saya tak mau terima sebab saya tahu. Okay, 1010 okay, saya kena jawab juga. Dalam logic, we represent two true value T or F. Okay, what you say 10 just now is known as Boolean logic, dan Boolean logic is represented by 1 or 0. Sebab dalam subjek ni you tak belajar Boolean logic. Boolean logic mungkin korang belajar nanti. Saya tak benarkan kamu guna 10. Tak boleh jangan
Baik sir.
Walaupun memang betul T is 1, F is 0, tapi untuk topik ni ialah logik. Logik dia tak guna 10. Kalau Boolean logic saja guna 10. Alright. Disjunction sudah. Okay. Bayangkan, okay. Imagine if you don't memorize this, it will be hard for you to develop this. When I try to develop this compound proposition just now, saya dah hafal lah. So elok kita hafal. Lama-lama senang nak jawab. And there is no memorized technique which is better than doing the truth table itself. Kalau buat banyak truth table, banyak soalan, exercise, you guarantee boleh ingat secara automatic. Okay. Now I want to proceed to this properties, conditional. P implies Q. If P, then Q. This one I need to emphasize because this is the common mistake or the common properties that most students forget. Okay. For P and Q, P implies Q. Okay. Nampak innocent je, tak susah. Students selalu silap because this is direction sensitive. The arrow represents to the right. T, T, F, F, T, F, E, F. T, if T is the condition, Q is the implication. T implies T will be T. T implies F will be F. F implies T will be T. F implies F will be T. What is Q implies P? First of all, P implies Q is not the same. It's not logically equivalent with Q implies P. Guarantee. Because it is direction sensitive. How to develop Q implies P here? You don't read from the left to right, but actually from this table is from the right to left. So T implies P, dia jadi T. F implies T, dia jadi T. T implies F will be F, and F implies F, of course it will be T. When you observe here, for P implies Q and Q implies P, the order is different right now. For P implies Q is T, F, T, T. For Q implies P is T, T, F, T. This indication alone show you that these two are not the same proposition. Kalau kita tukar dalam English pun dia tidak sama. Alright. What I meant with when you tukar dalam English dia tidak sama. Please refer to the slide on the left. P implies Q says that if today is raining, then I will bring umbrella. If Q implies P, dia jadi if I bring an umbrella, then today is raining. Okay, try to read this statement, both of them, for a while, and you will sense that these two really does not represent the same meaning. The first one, P implies Q. If today is raining, then I bring umbrella. Okay. The second one, if today I bring umbrella, then today is raining. These two compound propositions actually holds the different logic. Okay. For my conclusion, please do not, please give emphasis on the direction. Okay, ada soalan? Kita dah tidur? Belum Oh, pukul 3. Alright. Before we take a break, I still need to finish this one to have an impact. Alright. This slide saya tak suka sebenarnya. Okay, mesti ada tanya, sir ke yang buat slide ni? Saya ambil dari orang juga, kawan-kawan saya juga, saya letak kat dalam ni lah. Nak cepat, tapi nak ajarnya tak tentu sama lah. Because this is from the Rosen book, yang mana saya tak share lagi, nanti saya share. Buku Rosen ni menunjukkan, saya share dalam kalam, saya tak share dalam Google Classroom saya rasa. Okay, they said, according to Rosen, which is also true by the way, all these 12 statement here represents P implies Q. We only learn if P then Q. Tetapi P is sufficient for Q also means if P then Q. Bagi saya, serabut. Okay. I'm a very simple direct man. If then, sudahlah. During your lesson on modern mathematics, form forward, mathematical reasoning, dia direct je, if then. Antecedent, consequent. Condition, implication. So if P, it means P is the condition, Q is the conclusion. Seriously, saya tak suka guna yang lain. Saya akan guna if then je. So don't bother to worry about to memorize this thing at the bottom here. Daripada 2 sampai 12 ni pening bagi saya. Sepatutnya kita nak formalize benda ni dalam logical language. Dalam bentuk P implies Q, if P then Q, senang je. Tetapi kita bukan belajar English. No need to worry for the other representation of P implies Q. Okay? Nanti, yang ni sambung nanti. Tapi saya nak terus kepada biconditional. Okay. P, if and only if Q. Alright? Memang dia guna verb tu, if and only if Q. Why they are both direction? Because it actually must be, both direction must be true. And how to represent this into a truth table? Only when it has the same truth value, then it will be true. So, same TT jadi T, FF dia jadi T. If you have different truth value, it will be false. Itu je. For this case, you tak payah risau terbalik. Because P if and only if Q, and Q if and only if P, it will be the same. It is not direction sensitive. Alright. Should you have any question, you can ask now. If not, we will take a break for 5 minutes perhaps.
Saya tak faham yang satu arrow.
Yang satu arrow yang apa yang kamu tak faham?
Yang tadi tu lah, P satu arrow Q.
Saya tak faham soalan awak. Saya tanya balik.
Implication kot, apa?
Apa nama dia tadi?
Conditional tu. Ya.
Implies left to right arrow tu sir. Yang Q to P, P to Q.
Okay.
Itu biconditional.
Dah, itu by conditional. Yang soalan kawan-kamu ni ialah conditional. Dia tak faham yang tu. Alright. Saya terangkan. Okay, saya tak mau tunjuk slide. Sebab takut memeningkan kamu lagi. Just now, I say, okay, P implies Q. Directionnya hanya to the right. Hanya ke kanan. T, T, F, F. T, F, T, F. And T implies T, T. T implies F is F. This one will be T. Just now, dalam slide, dia tak ada Q implies P. Saya faham. Kenapa saya sengaja adakan Q implies P? So that the student know that this one, dia ibarat ni tau. Saya kena padam balik. Kejap. Okay, saya buat 3. Okay. P, Q, saya tulis balik P kat sini. TTFF, TFTF, TTFF. This P is the same like the first P. Okay, P implies Q. T, F, T, T. Q implies P. Okay? Fokus kita tak faham tadi tu. Normally student, they did not write the second P here. Normally they don't do that. That's why sometimes they are wrong to say that sebenarnya Q implies P kat sini, dia baca daripada kanan ke kiri. Tetapi kalau saya wujudkan lagi satu P kat third ni, dia sebenarnya sama je. Baca kiri ke kanan. So T implies T will be T. F implies T will be T. T implies F will be F. And F implies F will be T. Nampak beza? Normally, saya ulang balik, normally students they did not write this one. So sometimes dia baca terbalik. They read it, entahlah saya tak tahu macam mana dia orang baca, terbalik lah. Bila terbalik, dia jadi salah. So actually, dia confused sebab yang ni ke kanan. Tapi baca ni ke kiri kan. Sebab dia confused. Actually, kalau nak senang, kita wujudkan second P ni. Bacalah kiri ke kanan. Dia tak akan terbalik kalau wujudkan second P ni. Tapi macam saya ulang balik, dia orang selalu tidak buat second P ni. Tu yang kena hati-hati dalam pembacaan. You must be very attentive when you want to construct Q implies P. Dia baca, yang ni adalah condition, T implies T jadi T. F, bila dia jadi condition, D implies T, dia jadi T. T implies F jadi F, dan F implies F of course jadi T.
Faham.
Okay. Soalan lain? Ini yang bahayanya. Only this logical connective is very dangerous. Okay, next question.
Sir,
Yeah.
maksudnya Q implies P tu salah ke betul?
Salah ke betul? Untuk soalan apa
Q implies P.
Q implies P, okay.
Maksudnya salah ke betul?
Okay, saya ulang balik. Soalan awak ialah Q implies P salah ke betul? Saya tak tahulah, bergantunglah pada soalannya. Tapi the thing is, the properties, kalau Q implies P, itulah propertiesnya. Yang saya kurang faham tu adalah salah untuk soalan mana. Kita
Dia
tak boleh
punya TTFT tu kan? TTFT. yang macam sebut tadi tu lah. Dia cakap terlalu general kalau ikut dia punya order TTFT kan. Yang tu.
Ya. Kalau kita guna initial yang sama saya ulang, kalau guna initial yang sama.
Sir,
Ya.
saya rasa diorang tak faham kenapa bila true false dia jadi false, kenapa bila false true dia jadi true. Saya rasa diorang tak faham yang tu.
Oh, yang tu. Okay. Okay. Itu first of all, itu adalah properties dia. When my first time I learn about this logic ni properties bahagian ni, maybe some of you question this, most of the students also question it, and I also question that. Kenapa T implies T jadi T? Kenapa T implies F jadi F? Kenapa F bila jadi condition implies T jadi T pula? Alright. Yang tu saya akan jawab, tapi sambung lepas saya break kejap. Saya suka jawab soalan tu. Kebanyakan student yang attentive, dia persoal. Dia persoal benda tu. Saya pun persoal. Sekejap. 5 minit, pergi toilet. Nak pergi toilet, pergi kencing ke? If you want to wash your face je.
Jawapan dia sebab Q implies P. So dia refer pada P lah, ambil yang P sahaja.
benda, sekejap. P nak Q kalau if student ask this, why when P is false and Q is true, then P implies Q is true is or false? Why when P is false and Q is true, then P is true? Oh, okay. How would answer then? Ni yang tadilah. Okay. I think because we implies apa kau tulis ni? Sekejap. Soalan yang notanya tu aku faham, tapi kalau Q implies P tu kira betulnya salah. Oh, Alia bahaya ni. Terlalu dia hafal. Okay, tak apa. Alright. Kejap. Oh, boleh buat magic. Ikut row jawapan dia. Correct. Tapi kalau Q implies tu kira salah ke betul sebab P implies Q TFTT. Saya masih cuba faham apa yang Alia kurang faham. I'm back. Okay. Kejut semua orang. Alright. I try to start first with the fundamental back. Adik. Beri canvas. Okay. Dia sebenarnya simple je. P implies Q. Benda ni. P implies Q. Okay. Properties asalnya, if P is on the left, normally kita susun P kat kiri. Okay, P, Q. P implies Q, okay. So dia jadilah T, F, yang macam Aiman cakap tu betul. The answer should be according to the rows. This is the basic form. Basic sekali. If T is the condition, P ni condition, okay. R ni adalah implication dia. So, Alia lari. Kenapa left? Tak apa, nanti dia masuk balik. If T is the condition, implies T will be T. T implies F will be F, the other is T. Itu paling basic. Paling basic. Tetapi kalau contoh saya tanya soalan lain lah kan. Soalan lain, korang duk hafal sangat P and Q tu kan. Bahaya juga. Boleh tak saya tanya R implies Q? Boleh je. Tak ada masalah R implies Q. Tak ada P kali ni sebab fokus sangat dekat P. Okay. R, Q. Ada dua saja. T, F, TF, and R implies Q will be T implies T, F, T. Sama je. Yang menjadi masalah if like this. Tadi kan saya tanya R implies Q betul? For example only be careful takut student pening pula ni. Sebab saya tengah nak orang kata apa tu, empathy dengan student yang tak nampak benda ni. Apa jadi kalau saya mula dengan Q dulu? R.
Salah.
Tak salah. Tak ada masalah. Bahaya awak cakap salah tu. Sebab tu
kita ambil jawapan Q sajalah kan? Betul?
Apa dia?
Kita ambil jawapan Q saja kalau ikutkan macam tu.
Dia ambil jawapan Q saja.
Cuba try habiskan dulu.
Sir, apa yang jadi hipotesis? R ke Q?
Q kan? Q. Sebab dia arrow to Q. So kita ambil jawapan Q. Dia punya
inilah
answer.
Condition. Inilah
Implies.
implication dia atau conclusion dia.
Kita ambil implication kan, jawapan.
Kita ambil dua-dua lah.
Ya, cuba try.
Okay. Yang tengah bercakap tu relax dulu, jangan tutup lagi. Alright. Sekarang ni, boleh tak kamu bagi tahu aturan Q tu? Nak TTFF ke nak TFTF?
TTFF.
TF.
Okay.
Q
Kamu
tu
nak
FFTT.
ah,
TFTF.
okay. Normally saya buat dua-dua. Saya buat dua-dua Satu student nak TFTF, satu lagi nak ni jadi TTFF. Satu lagi pula, okay. Nak bagi nampak lah saya dah faham dah apa yang budak pening. Saya cuba buat according to the normal TTFF. Ini jadi TF. Okay. Refer balik dekat slide tu, open the slide bahagian conditional tu. Okay. Yang mana depan, mana belakang. Alright. For the first one, the second one. Okay, tutup mic jap. Alright. For this one, R implies Q. Saya baca macam mana? R di depan. R is the condition. So T implies T. Dia jadi T. T implies F.
False.
False.
F.
T. Okay. Ini betul.
Saya rasa
Okay.
baru sekali T.
F implies F memang T. Itu properties dia. Itu memang properties dia. F implies F memang T. Saya boleh jelaskan kenapa dia properties dia macam tu. Tetapi if you ask the question betul ke salah, memang tak salah. Okay. Saya teruskan dekat bawah ni R implies Q. Sama juga. Kali ni saya susun. Saya sengaja bagi kamu pening. Ialah you need to read from the right to left. T implies T. T. F implies T. Saya ulang. F implies T. Dia jadi T.
TFT.
T implies F jadi F. Dan F implies F.
T.
F implies F. Korang ni kat balik ya.
Right.
TFT.
F implies F. Salah nota pula. F implies F is T. Normally, student, kalau P implies Q balik, saya balik kepada, klik canvas. Normally R implies Q. Saya faham. Kalau R implies Q, student susun R, Q betul. Dan R implies Q. However, in the question, sometimes, apa kata tiba-tiba saya tanya, R implies Q and Q implies R. Soalan yang macam ni student akan, sometimes dia confused dan dia akan silap atas dasar ini. Sebab dia hafal sangat R implies Q, Q implies R, dia dah jadi bingung. They confused because they don't know the direction. Always remember what's on the left is the condition. Dia implies yang di kanan. Sebab tu kalau boleh, buat exercise lebih bahagian ni nanti. Supaya kamu tak keliru.
So ada exercise kat PowerPoint tu. Muka surat 28 contoh.
28. Oh, tadi kamu ada type Sekejap. 28. Ni. Saya tak tahu muka surat 28.
Saya tengok ya slide yang kat kalam tu sebab dia ada.
Saya kalam. Okey. Tak apa. Nanti dulu. Saya boleh bagi soalan lain. Tapi buat masa sekarang firm dulu dengan properties tu. Alright. Right now I will try to answer. Ini soalan kenapa PQ tadi, P implies Q. Saya tulis balik asal. TTFF, TF. T implies F. T implies T. Ingat balik T implies T is T. T implies F is F. F implies T is T and F implies F is T.
True.
Okay, ni properties je. Okay, right now I try to explain soalan yang saya sendiri argue dulu, kenapa bila F kat depan, apa yang berlaku di T dengan F kat belakang jadi T. Specifically this row. Okay, in many of the discrete mathematics textbook, dia selalu bagi contoh ni nak menjelaskan perkara ni. Okay, P I define as if my mark over 80. Tak mau over 80 lah, tak realistic. 40. Okay, the passing cost for this DMS is 40 by the way. Q pass. Okay, simple je, saya tak nak panjangkan perkataan. Tetapi apa maksud P implies Q? If my mark over 40, then I pass. Setuju? Setuju. Kena setujulah, memang markah 40. Alright. Right now we try to make sense of these properties. We start first with the first one. T. Okay, ready ya? If my mark is over 40 is true, then I pass is also true. Betul tak? Logik tak?
Logik.
Logik lah.
Logik.
Memang logik. Jika markah saya lebih 40, then I pass. Logik, memang true. Tak ada persoalan kat situ yang kamu akan question. Kita pergi yang kat kedua. If my mark is over 40, then I fail.
False.
Kalau kamu student kalau kamu student, maka kamu lebih 40, tetapi saya
Mana
bagi
boleh?
Mana boleh?
Marah.
Marah lah.
System.
The implication is false. Tak betul dah tu. Kalau markah student lebih 40, you should pass but I give you fail. So the implication dia adalah false. Senang lagi. The first two row memang senang. Okay, now comes to the next one. Next third and fourth. If you don't get 40, tetapi saya bagi kamu pass. Okay,
True.
I use the same explanation like those Rosen book lah.
True. Okay je.
True,
Okay.
sebab makan kesian.
True.
Mesti kamu bagi.
Pakai assignment.
Tak nak pass.
Pakai assignment.
Maka assignment tak lah. Ni kata-kata ada assignment lah. If you assignment pun dikira lah 40 ni awak. Bukan final exam je. Okay, saya balik fokus. If my mark is not over 40 but I get pass, student selalunya tidak komplain. Tak pernah akan komplain lah. Dia akan true. Okay. Ini explanation buku Rosen. Sebenarnya saya tak suka explanation tu, tapi saya terpaksa guna analogi kepada student. If you don't get over 40 and you fail.
True.
Betul lah. Memang betul lah. Logik. Memang logik. The implication is still true. Okay. In the search of nak puaskan hati saya tadi tu. Okay. Nombor 3 tu. Okay. Saya tak berapa suka dengan analogi tu. Actually, when I question this property, I come up with this conclusion. Okay, as a mathematician, saya suka explanation ni tapi mungkin student saya tak suka lah. Why F implies T will be T? Okay, ni explanation sebagai seorang ahli matematik ialah when condition is false, we don't have the proof to show that the conclusion is false. Therefore, the implication is true. Okay, saya jelaskan apa ini. In logic world, you ada true atau false saja. Okay. If the condition is failed to be satisfied, if the condition is false, you don't have enough implication to show that it is false, therefore we assume it is true. Okay, mungkin ada ramai student tak suka penjelasan ni, tapi penjelasan yang ini memuaskan hati saya. Oh, diam terus. That is the reason. We must choose either true or false, but if the condition is not fulfilled, kita conclusion must be assumed to be true.
Macam
Sekejap, apa ni? Yes, this is how the book explain this. This is analogous to vacuous proof. Wah. Apa tu vacuous proof, Leong Tenman? Can you explain it to me? Oh, Leong. Tak, serius saya tak tahu vacuous proof tu apa. Bukannya saya nak uji awak. Vacuous proof tu apa? Leong!
Hello, sir.
Yeah, what is vacuous proof?
Honestly, I don't know how to say vacuous proof. Just when we're doing some proof, we will suppose some assumption and also the conclusion, so that when we know, let us suppose that P is our supposition, and then the hypothesis is R implied S. So we know that if P is false at first, but so I mean that the initial assumption is false, then our hypothesis will not affect by the supposition.
Betul. Saya setuju dengan statement tu. I agree with that statement. So memang vacuous proof ke?
Yes. And then the hypothesis is not necessarily true for all value of X, but the hypothesis will work for some certain value. This might be the reason why the implication have such properties.
Okay, I will read more on the term. Saya cari kat sini. It's a trivial proof. Yeah. What you said is almost similar with my explanation just now, actually. Thank you so much for sharing. Saya nak kena tengok WhatsApp sekejap Nik Muhammad Farhan, apa ni? Dari library mohon diada bla bla bla. Kalau tak baca nanti kena marah pula. Alamak, Dr. Anwar Aziah. Oh, your screening test result. Aduh. There will be a bridging program, by the way. And the data analytics lecturer will be the one who teach you guys. Sekejap saya nak baca bila saya kena. Tolonglah saya di belakang. Saya di week 5. Korang ni kenapa tak lepas screening test Biarlah. Alright. Can we go back? Alright. Clear canvas. Alright. Kita teruskan Kita akan habiskan di sinilah nanti. Alright. Suppose that you already memorize this thing memorize all the logical connective properties. Now we actually try to do the table. Okay. Macam yang siapa cakap tadi tu soalan ni. Okay. We try to develop this time. Kita we start small Saya tak buat habis. Saya buat yang ni dulu. Okay, are you guys still with me?
Yes,
Yes.
Alright. Suppose you get this simple statement. Develop a truth table for this compound proposition. You have not, you have bracket, and also you have and there. Alright. The basic fundamental thing that you need to have is that how many rows, betul? Dan kerana menangkan kita hanya ada dua proposition, you only have P, U, and T, T, F, F, T, F, T, F. Alright? Now, kita buat apa dulu? Kita buat apa yang dalam bracket dahulu. Not Q. So, by using you punya properties dalam kepala kamu, this will be F, F, T, F, T. Okay, my precaution for you guys, and girls, before you proceed to develop the next column, please ensure that your previous column is correct first. Because when you are wrong, for example, katakan tersilap sini, it will affect the new column provided at the right later. So before you proceed, please double check, please triple check, quadruple check to ensure that this representation is true. Okay, peringatan saja. Okay, now we proceed with P and not Q. Ni kita dah buat dah tadi tapi kita ulang balik. T and F, we will be F. T and T, we will be T. F and F will be F. F and T will be F. Now we can open the bracket, not P and not Q. So it will be the negation from the fourth column. F jadi T, T jadi F, F becomes T and F becomes T. Now for right now, for your exercise, I will ask a random question. What is P or not P or Q? Cuba buat. In 2 minutes. What will be the true values for not P or Q? Ni masih senang soalan ni. Oh, dah jawab dah. Oh, laju korang. Okay, TFTT. Okay, I'm also not sure about the question yet because I don't develop it So let me give time for me for a while for ni. Okay, give me time for a while to verify your answer. Okay. Alright. So again, the same manner, you should have 2 rows, PQ, TT, FF, TF, TF. Okay, I should do not P first. You will be FF, TT, then not P or Q, not P or Q, FTT, F, TT. So it will be TF, sorry, TT. Tengok apa yang korang tulis. TFTT. Thank you, betul. Betul. Saya suka macam Muslim tulis ni. Betul-betul ikut row senang. Arti tu benda repeat Alright. Alright, very easy right? Dia tak susah kalau simple Kalau dia main banyak. Dan selalunya okay, like I said the students always happen to do mistake during the implication. So boleh tak saya bagi satu soalan implication? Conditional lah, conditional. Alright. Berikut adalah soalan dia. Q implies not P and Q. Ambil kau. Okay lah, nak menyenangkan kamu sikit saya buat bracket lah. Sebenarnya tak payah pun bracket tu. Tetapi for like I said, this is the first class nanti kamu drop khusus ni susah saya. Okay, Q implies in the bracket not P. And Q dah buat belum? Okay, buat Okay, please try to do this in 1 minute. Soalan ni mungkin ada pelajar terconfuse kejap dan saya tak harap kamu silap lah. Oh, ada dah jawapan. Aju. FTTT. Okay lah, cukup lah. TT. Okay, ada seorang TT dulu. Okay, interesting. I also don't know which one you are correct. FT kuasa 3. Wah, pandai kau tulis Oh. FTTT. Okay. Let's try to verify the results because some of you guys dah dapat. Okay. Of course, as usual, PQ first T, T, F, F, T, F, T, F. Okay. Not P. F, F, T, T. Not P and Q. Nanti saya lukislah Not P and Q. F, F, T, F. Q implies not P and Q. TF will be F. F implies F will be T, T, T. Alright, let's look. Betul tak jawapan saya dengan kamu? FTTT. So to those of you, if your truth table looks like this, then 1 mark, 1 mark, 1 mark, 1 mark. 4 marks. Tahniah untuk kamu. Okay? Ya.
Sir,
Betul.
kalau saya buat Q tu sebagai yang hipotesis boleh ke?
Q dulu sebagai hipotesis. Memang Q adalah hipotesis.
Q hipotesis lah.
Condition lah. Saya takut
Condition.
pemahaman saya takut salah dengan kamu. Hipotesis. Bagi saya is
So
condition.
P akan jadi conclusion lah kan? Implication kan?
Keseluruhan dalam bracket tu adalah implication.
Okay, terima kasih.
Sama. Keseluruhan tu adalah. Okay. Good job guys and girls. Alright. Kenapa live meeting lah tak habis lagi. Alright. Kita teruskan kita sampai logical equivalence lah. Boleh? Alright. Mana saya ni? Alright. When you already know how to develop the truth table, there is some properties atau the benefits of knowing that. Just now, I already said that P implies Q is not logically equivalent with Q implies P. Tadi saya dah bagi contoh ni tadi. Right now, how to use the truth table to verify whether it is logically equivalent or not. Okay? You must know first the concept of tautology. Okay, contradiction and contingency. If the compound proposition always true, yakni if all of the truth value exhibited in the column, all of them are true, then it's tautology. If all of them are false, we call it as a contradiction. And if you have a mixture between F and T, we call it a contingency. So from the previous truth table just now that you already developed, you tengok dekat compound proposition dia tu, dekat kolom paling kanan tu. Adakah dia tautology? If it is a tautology, then all of them are true. If contradiction, all of them are false. If campur-campur, then it's a contingency. Okay. Now, how to show that this is logically equivalent or not? By using this definition. P and Q are logically equivalent if the biconditional between P and Q is a tautology. Now, I want to show what is the meaning of that sentence. Okay. We start first with PQ, TTFF, TF, right? Then I should do P implies Q first, which is T, F, T, T. Q implies P is T, T, F, T. All right. It is logically equivalent or not. The simplest explanation that can be said by most of the students, dia cakap, this is TF, TT. Yang ni pula TTFT. Tak sama. It's not similar, therefore it's not logically equivalent. You happen to be right if you think in that sense. But the formal definition says that you must check between these two proposition, these two compound proposition. Saya kena check biconditional between them first. Okay. So biconditional hafal TT T, FT, aduh, FT dia F, TF F, and TT is T. Now let's look at this. The biconditional between P implies Q and Q implies P is not tautology. It is contingency, right? to be precise. As P implies Q by conditional with Q implies P is not tautology, therefore I conclude that P implies Q is not verified, that is not logically equivalent with Q implies P. Okay, any question about this example? Okay.
Sir,
Yeah.
kalau kita nak tentukan sama ada dia equivalent atau dia tak, kena buat by conditional.
Lebih elok kalau kamu buat.
Oh.
Okay, I will explain. Some of the student from previous semester, dia bagi jawapan ni. Katakan kan, dia orang tak buat ni kan. Ada setengah student dia tunjuk ni je. Okay, bayangkan yang biru di kanan tu saya tak ada. Bayangkan tak ada. Dia bagi saya jawapan ni je. Apa maksud dia? Okay, what I want to say, my point right now ialah saya tak tahu dia faham ke tak. Sama ke tak? Adakah dia menggunakan konsep ini menjawab kepada logical equivalence? This is the worst answer possible. This is the second best answer. You want tulis same. Okay, if the students tulis same like this, sometimes I accept sebab dia betul theoretically. But the best possible answer is that they show that those two are not tautology. They show the best answer. They show the biconditional between those two compound proposition is tautology or not tautology. Yang tu terbaik lah. However, if the student do this like this, same what? Same truth value. Boleh lah saya terima juga sometimes. Depends on the distribution of the marks. Okay? Okay. I try to give you one example, a very easy one. Determine whether P biconditional dengan Q is logically equivalent with P implies Q and Q implies P. In 2 minutes. Aduh. Okay, for the purpose of this, can I see your actual working this time lah for this question? Bila you dah siap, would you like? Saya tak nak jawapan last je. Saya nak tengok semua jawapan tu. Boleh? Bila dah siap, someone hello me atau bersuara, you can show your answer. Dengan kamera ke apa saya tak tahulah, tangkap gambar ke, saya nak tengok. That you actually can do the whole solution. Aduh. Mana soalan tu? Example 6. Example 15. Dah ke? Dah. Boleh Aida tunjuk jawapannya? Solution penuh, bukan jawapan last je. Boleh ada cara nak tunjuk tak?
Tak boleh lah select kan.
Tangan gambar ke? Share yang WhatsApp tak apa. What? Saya tunggu Boleh kata ni soalan last lah. Lepas tu kamu semua boleh berehat lah kalau nak. Thank you. Ni soalan siapa ni? Oh. Okay. Saya tengok jawapan Muhammad Akram. Oh, ada lagi satu. Saya cek dua-dua cukup jawapan Muhammad Akram dengan Izzati. Kita boleh tengok sama-sama dalam WhatsApp. Okay, please look together in the WhatsApp. Okay, terima kasih Nick. Cukup dulu. Banyak sangat pun pening. Saya tak sempat semak semua. Okay, TFTT. Muhammad Akram, kamu tidak buat P implies QN. Okay, kita tengok balik soalan Soalan saya ialah P by conditional kamu buat, kamu tidak buat yang di kanan ni. Ni kanan ni. Okay, so kamu dah salah dah kat situ. Tak cukup. Soalan siapa ni? Jawapan siapa ni? Aida. Okay. TFFT betul. P implies Q betul. Betul. P N E F F T betul, tapi kamu tak bagi tahu kenapa dia logically equivalent. So kurang satu markah kat situ. Okay, jawapan Nick Nurul Syuhada. Okay, sama juga dengan Aida. Okay, please put why they are not atau why they are equivalent. Kena letak. Kenapa dia equivalent? Okay, saya shortcut Saya tulis jawapan Nick ni. Alright. I will only put the last one. P implies Q dia tulis T F F T. And this one P implies Q and Q implies P adalah T F F T. Okay, this is what she wrote. At the end, directly conclusion. Soalan saya, adakah dia logically equivalent? Technically,
yes.
Yes, betul. Yes, betul. Because tu kurang. Okay, macam saya dah explain tadi, some student they say same. Ada yang jawab macam tu saya bagi, tetapi the best possible answer is actually they try to determine the biconditional between those two compound. Biconditional besar kat sini. Ini sorry tak ada space. Buat lagi satu kolom. T and T biconditional dia ialah T. Yes, it is equivalent because it is T implies Q by conditional is tautology. Thank you. That is the best answer. Alright. Well done kepada yang terkurang tu, perbetulkan balik. Jawapan Syaza betul. Tautology, hence.
Sir, kena tulis ke yang panjang-panjang tu? P, yang dia punya condition tu semua before tautology tu.
Okay, saya jawab. Ada some of the student, they found it is too long. Sometimes they put like this Dia letak macam ni je. Okay je. You can write of course all of it. But some students simplify it like this, I accept. They represent P implies Q, P if and only if Q as 1, and the next form of proposition is represented as 2. 1 by conditional with 2 is tautology, therefore it is logically equivalent. Saya terima.
In real exam pun terima juga.
Terima.
Okay, thank you.
Yang kena tolak markah kalau tidak buat compound proposition dan tidak menyatakan kenapa dia equivalent. Itu saya terpaksa. Tak terima. Tak terima jawapan. Okay. I think we are already at the end of the session today. Cukup 1 minggu, tetapi sekejap saya tengok jadual. Oh, lama tak mengajar. Mana jadual kamu? Aduh. Ni dia. Okay. The next lecture should represent predicate and quantifier. Okay, technically you boleh jawab quiz dah for the first quiz. You quiz nak Selasa ke Khamis? Nak Selasa ke Khamis?
Khamis.
Khamis.
Rasa
Khamis.
Terus sekali.
Nanti ada homework bercanggah semua. Khamis dah habis dah kelas.
Okay, tak kisah. Saya tak ada masalah. So still follow schedule lah. Khamis will be your first assessment, and the thing that we already learned today should help you to answer the quiz, the first quiz. Individu lah juga quiz, jangan nak group pula. Next week kita akan proceed with predicate and quantifier and the introduction to proof. Okay, last word from you guys kalau ada.
Sir,
Yeah.
Khamis tu esok ke?
Kami minggu depan lah.
Okay.
Kan kata esok public holiday, patutnya yang esok tu jadi hari ni, esok tu esok, tapi sebab kamu cakap free pukul 2, saya bawa lah ke depan. Itu je. So esok tak ada kelas lah. Nak kelas? Tak nak kan?
Tak apalah sir.
Tak apalah. Kalau saya kejam saya buat, lepas tu tulis kat UMP confession. Apalah lecturer di public holiday nak buat, padahal semua dah semua kata okey je kan. Okay, esok no class. Okay. So, Tajul esok jangan masuk kelas Tajul. Tajul ada ke dok ni?
Ya.
Ada. Allah, lama tak dengar suara Tajul. Tajul ni dia pemalu. Handsome orangnya. So, berani tak buka kamera Tajul?
Senior
Senior senior kamu kot. Yelah senior lah. Saya tak tahu senior ke tak dia. So, dia tu abang senior korang. Kalau ada apa-apa soalan boleh tanya dia lah.
Aduh.
Let lah Tajul.
Sir.
Ya.
Result screening test dapat tahu bila?
Screening test saya dah tahu dah result kamu. Dia dah share di sini.
Kita orang dapat tahu bila?
Saya tak dapat jawab sebab dia tu atas kuasa Dr. Nur Aziah. Cuma dia orang tengah kecoh lah sekarang ni. Dia cakap tengah membawang pasal result screening test kamu lah. Betul ke nak dengar ni? Saya boleh cakap. Okey.
Boleh.
Sekejap. So kita orang ada kelas.
Okey, pukul 4. Okey, silakan. Tak ada masalah. So tak kita tamat di sini.
Tak boleh.
So tak perlulah tahu apa yang kita orang tengok.
Nak tahu.
Tak payah.
Tahu sekejap.
So bye-bye. Kita tutup di sini. Assalamualaikum warahmatullahi wabarakatuh dan see you.
Thank you sir.
Thank you sir. Thank you sir.